Hi everyone, in today's lesson we are looking at Chapter 7, Section 3, Rotations. Our objectives are to identify rotations in a plane and to determine whether a figure has rotational symmetry. Our standards are G-code 2, 3, 4, 5, 6, 7, and 12. We start with some vocabulary. Rotation. A rotation is a type of transformation in which a figure is turned about a fixed point. Center of rotation. In a rotation, the fixed point is called the center of rotation. So as you can see over here, our center of rotation is this point over here, and we are taking our blue image or our pre-image and rotating it 120 degrees counterclockwise to get this red image. Angle of rotation. In a rotation, the angle of rotation is the angle formed when rays are drawn from the center of rotation to a point and its image. In this picture over here, we can see that here is our pre-image, and we're basically taking this pre-image and rotating it 60 degrees. That is our angle of rotation. Theorem 7.2, rotation theorem. A rotation is an isometry, meaning that when we do a rotation, the size of the figure does not change. When working in the coordinate plane, assume the center of rotation to be the origin unless told otherwise. A positive angle of rotation turns the figure counterclockwise, and a negative angle of rotation turns the figure in a clockwise direction. In a rotation of 90 degrees, since this is a positive 90 degrees, I know I'm going to go counterclockwise. What you're going to do is you're going to take your original x and y and switch them so that you get y and x, and then you're going to take your y value and write its opposite. So if it's a positive y, it becomes a negative y. If it's a negative y, it becomes a positive y. A rotation of 180 degrees, this could be clockwise or counterclockwise. All you do is you take your original x, y, and change the signs of both the x and y. And then a rotation of 270 degrees, this is a rotation counterclockwise. It is also the same as going clockwise 90 degrees or a rotation of negative 90 degrees. Here what you would do is you would take your x and y and switch places and change the sign of your x value. So it's going to be the opposite of what your original x value is. Rotations in a coordinate plane. Rotate triangle ABC clockwise 90 degrees about the origin and name coordinates of the new vertices. Now in this example, they're asking us to use a protractor and a compass and a straight edge, but I prefer to use the algebraic method. So we know since we're turning it 90 degrees clockwise that we're going to basically switch our x and y, and whatever our x value is, we're going to use its opposite sign. So in this case over here, point A is located at 3 and 2. After a 90 degree clockwise rotation, we're going to switch the 3 and the 2 so it becomes 2 and 3, and then change the sign of the 3 so we get 2 and negative 3. Same thing with B. B is at negative 1 and 5, so we're going to switch the negative 1 and 5 to get 5 and negative 1, and then take the opposite of our x value. So the opposite of negative 1 is positive 1, and so we get 5 and 1. Last, we've got 4 and 5, switch 4 and 5, so we get 5 and 4, and then take the opposite of positive 4, which gives us negative 4, so our new coordinate C prime is at 5 and negative 4. Alright, checkpoint problem number 1 and 2 is yours. Name the coordinates of the vertices of the image after the given rotation of triangle ABC about the origin. In checkpoint problem number 1, what are the coordinates after a 90 degree clockwise rotation? And in checkpoint number 2, what are the coordinates after a 90 degree counterclockwise rotation?